Hi, my name is Chinuka. I am an MSc Computer Science student at UCL, and this is a video demonstrating my mid-project progress for my end-of-year dissertation. MotionInput is a UCL-developed application for enabling users to interact with their computers touchlessly. It is currently on version 2.0 and is being worked on collaboratively by a team of students. However, each of us have our own individual projects centered around specific use cases, be that gaming, clinical, office work, or rehabilitation. These span a variety of different interaction types, and that can be body, voice, hands, head, or even eyes. My particular use case is centered around clinical use for 3D model navigation, specifically 3D scanner manipulation in another UCL developed application, the Holorepositoty portable viewer. In this video, I will briefly go over my use of speech-to-text and hand tracking for rotating, zooming, and panning models in the Holorepository, as well as recording annotations. Rotating is quite straightforward. Simply pinch your index finger and your thumb and drag to rotate. Sometimes the pinching doesn't get detected, likely due to underlying confidence values of hand coordinates in MediaPipe, often affected by poor lighting conditions or finger occlusion caused by awkward hand positions. This is something I will be looking into improving in the latter part of my project. Zooming is performed by pinching your middle finger and thumb on both hands. Pull your hands in and out to control the amount of zoom. This is inspired by touchscreen devices and multi-touch, and how zooming is performed on them. Panning is done with the on-screen joystick. To initiate it, engage the rabbit pose shown in the bottom left in red. This joystick also has potential use in video games and can allow for 360 degrees of motion. You cannot see this in the video as the Holorepository only allows for either horizontal or vertical panning at a single moment. You don't need to release the joystick early as I have done in the video either. You can simply hold the rabbit pose as long as you are using it. Some more work needs to be done on making sure the joystick is activated and deactivated closer to when the user wants it to be. This is another joystick mode of use, which I call toggle mode. You activate it with a gesture, then you can move your hand as you please, even performing other gestures while in use. You deactivate it with a gesture when you don't wish to use it anymore. This could come in handy when, for example, you want to jump and move at the same time in a video game. Lastly, the Holorepository viewer also allows the creation of annotations. For this, I needed a way to get text on screen sans touch. I opted for speech-to-text because that seemed far easier than using an on-screen keyboard. And watch the video for a demonstration. There is a tumor in the frontal lobe. And there you go, the speech-to-text translated that on screen quite nicely. So currently I'm using Google's speech-to-text API via Python's speech recognition library. However, ideally for clinical applications like mine, I can find another API or model which can suit the privacy requirements of my application. And that concludes this video. Right now, the core functionalities, all of them can be performed in the Holorepository touchlessly. I hope to upload another video at the end of this project to show the finished product. I'm also hoping for some significant progress towards accuracy and usability. Thank you for watching, and I will see you on the other side.